So now we'll talk about some properties of the cross product, and we'll make reference to the full definition as we go through these. The case that often comes up is that you cross two vectors that are parallel with each other. And in this case, if we look at the definition, if they're parallel, it means the angle between them is either 0 or 180. And in either case, we get sine of theta equals 0. Note that this is the 0 vector, not the 0 scalar. Related to this is another useful thing to remember, which is that any vector crossed with itself is equal to the 0 vector. The next property, which we already talked about in the previous video, is that the cross product is not commutative. Instead, if you reverse the order of the cross product, you have to introduce a minus sign. In the same way as the dot product, the cross product is distributive across addition. And here we have a slightly harder example, where just like we did with the dot product, we're going to cross A with C and D, and then cross B with C and D, which gives us these four terms. And just like the dot product, we can draw scalars out in front. The cross product is not associative, which means that the order of operations matters. So for example, A cross the quantity B cross C is not equal to A cross B crossed with C. And there's one more useful equation to know, which is the vector triple cross product, which lets us compute this series of two cross products with dot products instead, like this. And we note that A dot C gives us a scalar to multiply the vector B, and A dot B gives us a scalar to multiply the vector C. So when we subtract these two vectors, we get another vector, which is what we expect as the result of a cross product.